Here at the top of the Customer2 class code file, you'll find some using statements inserted by the class diagram tool. These statements simply make it easier for you to write the code. Because these statements appear at the top of the file, you can refer to any class within these namespaces without having to include the full namespace name. Why these 4 particular namespaces, though? Well, to tell you the truth, that's not totally clear, other than Microsoft apparently believes that you'll commonly use classes and other objects in these particular namespaces when writing code for a class in a console application project. But you can always add and remove using statements as you need them. Now, one interesting thing about the using statements is that any of the statements in a code file that import namespaces that none of the code currently uses will display in adult text. Now, that's not the case here. Let me come over to Customer 1. So you can see that there. In this particular code, all I'm using is the system namespace. I'm not using any of these others. So if in fact I've fully implemented all of my code within this file, I could go ahead and delete these. Or I can even right-click on this, select Organize Usings, and select Remove Unnecessary Usings. And that'll clean those up. I'm not going to do that here. So I'm a little bit not sure why that isn't here, except that I haven't built the project yet. So that may be why. At this point, Visual Studio doesn't have access to all of the symbols that are used throughout the project. And so you can see that the build is started. I'll select the output window there so we can see the progress. Oh, and build succeeded. Yeah, and it's still... Oh, there we go. Finally. Okay, that was what I was expecting. So it was just a matter of I hadn't built the project yet. So now technically, in theory, I could get rid of all these using statements, but my code will in fact make use of them as we start fleshing it out. Okay, the next up is the declaration for the namespace. Namespaces let your applications group code into logical entities, and by default, each class in your project belongs to a namespace with the same name as your project. But you can easily change that. And in a more complex application, it'll be very common where you'll have multiple namespaces. And in fact, other project types, the templates for them that Visual Studio includes, often have multiple namespaces. And those are generally of the form project name, folder name, as you put code into different folders. Okay, then here's the declaration for the class, the definition of the class. It's public. And this surrounds, I have brackets that surround all of the code for this class. Now the public keyword here is important because it means that you can create and use an instance of this class both from within the assembly where this is compiled and from outside the assembly as well. Okay? Now sometimes you'll want to make that private so that other applications can't use this code, only can be used in files that are compiled into the single assembly, but that's starting to get into a more advanced technique that you probably won't have to worry about for a while yet. Okay, then we have the field declarations here. These all include the private keyword because I don't want these to be visible outside of the Customer2 class. The property procedures will store and retrieve values that are stored in these variables. And notice that the class designer put them in alphabetical order. Order doesn't matter whatsoever. But with custom code, you'll probably want to put them more in a functional order. So maybe I would have address, city, region, country, and have all those fields together, and then have customer ID and customer name together. Probably customer ID and customer name at the beginning. It's a loose convention to put the primary key, what amounts to a primary key in database speak, the unique identifying value for a class first, and that would be customer ID. But that's by no means necessary whatsoever. Okay, then here's the single constructor. So again, this is the method that the CLR is going to call when I new up a Customer2 object. It'll call this code, and typically what you do in the constructor is initialize variables, and that in fact is what we're going to do with customer ID when we start fleshing out the code. And because there's no default constructor, a constructor that has no parameters, takes no parameters, you're always going to have to supply a parameter value when you create an instance of this object. So that was a design decision. You can create a constructor with no parameters. That's what we did with customer 1, but it's your choice. Okay, then after that are the property definitions. So each of these procedures, this is in fact a method, consists of what's called a getter and a setter. The compiler uses the getter part, the get method, when the code working with an instance of the class needs to retrieve the value of the property, is reading the value of the property. And then the compiler uses the setter part when the code attempts to set the value of the property. Now, the reason why there's only a statement that throws an exception in the getter is that this is reading the value of the property. There is no value of this property yet. We haven't written the code that does it. So we throw an exception because otherwise something wrong will occur. You're trying to read a value from a property, it's not going to get anything, and the calling code isn't going to like that. Okay, so we get an exception instead. That's not a problem with the setter. It probably would be better to throw an exception here as well because you might forget to implement a setter that you need to implement. But in this case, you just write the value. It goes nowhere because there's no code here. Again, in the calling code, you set the value of the property. It just disappears into the ether. Okay, there are all the property definitions. And last, we have the couple methods that we defined. Overloaded, taking different numbers of parameters, and so we can have multiple instances of update location. All right, so that's the code that the class designer created for us. Now we need to flesh out the code, and specifically have to modify the country field so that it supplies a default value of USA. Default values for properties are nice things. I need to create code for the constructor, and for that I need to store the passed-in value of the customer ID into the private _customer ID field. I also need to create code for each of the property procedures, getting and setting values for each of the private fields, and then create code for the two methods, setting the values in those private fields. Okay, so let's get started with those tasks. Now, there's several different ways that you can assign a default value. I'm just going to go ahead and assign a value here. So when this private variable is declared, I'm also going to initialize it to USA because it turns out that 99% of our customers are in the United States. Might not be a good idea to do this if we're truly a global company with customers all around the world. Or for a Canadian company, we could set it to Canada, whatever. Okay, now I need to implement the constructor. First thing I need to remember to do with all of these methods is to get rid of that throwing that exception. And here all I need to do is use the customer ID. I'm going to assign the value of that parameter that was passed in. All right, so when I call the constructor, pass in a customer ID value, it's going to assign it to the field. Now, one sort of funky thing here is that I have a customer ID and I also have a property customer ID there. So I have a parameter there and I have a property. Because this customer ID has a smaller scope, it's going to override the visibility of this customer ID. So probably what I'd really do in a real-world application is make that a lowercase c, and then they're uniquely distinguished. But it really doesn't matter because the compiler can sort them out and figure out what's going on. Okay, so that's all we need to do for this very simple constructor. Now let's look at the customer ID property. So in this case, all I need to do is issue a return statement that returns the value of that backing field. Okay? It's going to read the value of that property. The property is stored in that private field, _customer ID. So I just need to return that value. And then similarly, to set the value, I need to set the value of that customer ID backing field. And I'm going to use it, I'm going to set it to the value of the value variable. Okay, so I'll talk about that in just a second. Okay, so this is the getter. It's important to understand that the purpose of the get statement is to return the value of the property. So the code that I've written here does that in the simplest possible way. It just returns the value of underscore customer ID. But you can write as much code here as you need to return the value. Maybe you need to hit a database, maybe you need to generate a random number, maybe you need to validate, do some validation. You can write as much code here as you want. Okay, then the set statement here. So the setter handles a situation where the calling code, the code that is using this object in memory, needs to set the value of the customer ID. So I'm using this value keyword. So where does that come from? Class properties all provide this parameter automatically and populate it with the value that the calling code that sets the property value to. So this is the value that the calling code is assigning to, in this case, the customer ID property. And this value always returns or has the same type as the property itself. So value in this case is going to be a string. If I had a property of type integer, it would be an int or different kinds of integers. If it was a custom object, maybe it was a customer XYZ class, it would have type customer XYZ. So the compiler takes care of all that plumbing for you. Okay, and once again, you can write as much code here as you need. And commonly, you might persist the new value of customer ID to some storage someplace, a database, an XML file, a file on the disk, whatever you need to do with it. Maybe you do some sort of validation. Okay, so that's a fairly typical way of implementing customer ID. But wait a second, this really isn't quite right. You might remember when I was talking about how this class was going to work, I said that the customer ID needs to be read-only. That means that external code can't write to this property. The only way the calling code can set the value of this property is through the constructor when the object is originally created. It can't be changed later. So we need to make it read-only. Fortunately, that's really easy to do. Hit the delete key, and now it's read-only. I no longer have a setter. I'll get rid of that line too. I no longer have a setter, so calling code has no way to set or change the value of that property. Okay, so by removing the setter portion of a property procedure, I make it read-only. To make a property write-only, which is a lot less common but does happen, you leave the setter in place, but you remove the getter portion. You only need to have one or the other. You have to have at least one of them, but you only need one of them. You can't have both of them. Okay, so let's go ahead and implement the customer name. Here I'm going to return the underscore customer name. And this property is read-write, so I'm going to now set the customer name equal to value. Okay, and so that fully implements customer name. And that's pretty much the same kind of code I need to do for the remaining properties. So I'm going to return underscore city and set the value of city. Same thing with region. And country. And postal code. Oops. And there's all the properties that are now implemented. So save the code, save my changes. And we're well along the way on fully implementing this customer2 class. And then the last thing I need to do is write the code in the two methods to store property values into the appropriate backing fields. So I'll once again, get rid of the throwing the exception. And all I need to do is read the different parameters for this method and assign them to the backing fields. So assign city, the new city. Oops, need an equal sign. Region, the new region. And postal code, the new postal code. Okay, so for this very simple method, that's all I need to do. Certainly, in a real method, I may do lots more. I could have dozens of lines of code calling other methods and so forth. It's virtually unlimited what I can do here. Okay, so just need to implement the other one. So I'm going to get a jump start on that, because all we need in addition here is to add the country. And save one more time.